Hi teacher and my friends. Today my team will present about the project 2, which is about the comparative analysis of PID, fuzzy logic, and FPID controller for the single tank water level control system. So my team has 2 members. My name is Tran and my friend is Huynh Xuan Tan. So let's start. This is the agenda of our presentation. So first we move to the introduction. So in real life, about 90% of practical control system, and in industry we use PID controller. For fuzzy can integrate in a robot system where no precise inputs are required. This is the diagram of fuzzy processing. So first we have the fuzzification, and in the middle we have the rule-based and the inference engine, and from that we translate the signal to the defuzzification, and it can be translated to the outputs or to the actuator. For the PID controller, it has 3 parameters, which is B stand for the proportional, the I stand for the integral, and the D stand for the derivative. So it has the formula to calculate the output signal to the actuator. For controlling the speed of the motor, we can use the BWM method. In explanation, we can adjust the duty cycle in the output signal to the motor, and from that we can control the water level in the tank. And for detecting the water level in the tank, we can use the sensor, which is ultrasonic sensor. This is the table. Is about how PID parameters affect to the response. So this method is also called the trials and error method, and we can use the method for the finding PID parameters. For example, when we increase the Kp or the proportional, we can decrease the rising time, the overshot will increase, and the steady state error will decrease. And for the fuzzy logic, in this tank system we use 2 common fuzzy set. It's in form of triangle and trapezoidal. These are the main components used in the project. We have the microcontroller, the tank, the pump motor, the driver for amplify the signal to the motor, and the ultrasonic sensor for detecting the level of the tank, and the power supply of the system. Next is the connection and control diagram of the system. So this is the connection diagram. The computer and the microcontroller will communicate together by serial, and from that we can make a simulation on the system. And from the microcontroller, we can interact with the driver by BWM, and from the driver we translate the signal to the pump, and it adjusts the flow rate in the tank. This is the control diagram of the system. So first we initialize the set point, and the E is the difference between the set point and the present value feedback from the sensor. After controller process the signal of the error, it will output the U signal. The U signal can be in form of BWM signal. So it going pump, and pump can change the speed of the motor, and from that we can change the flow rate, and the flow rate will adjust the water that flow in the tank, and from that we can control the water level in the tank. So this is the flow chart of the system. So first we have to type in the set point, and we must read the analog signal from the level sensor, and next we must convert the analog signal to the present level of the tank, and we also compute the E, which is set point minus PV. In this condition is about whether E is equal to 0 or not. If E equal to 0, you will apply the PID, fuzzy or FPID controller to output the PWM signal to the motor. And if not, or is false, we'll turn off the motor and we make it in the loop to keep the present value equal to the set point.
Hello everyone, my name is Huynh Xuan Tan. Now I will explain for you the model of three controllers that I use in my project. This consists of three controllers, PID, Fuzzy and Fuzzy PID. First of all, I wanted to talk about the driver. As you know, in this project we need to control the water level of the tank. So we need to read and display this value on the MATLAB. So how we can read the real value of water level to the MATLAB? We will use ultrasonic sensors. So how can MATLAB understand it? We need to install the driver. So we use Google here. Type Arduino Simulink. Arduino Simulink. In this link, the first link, download it, zip, yes. So I already downloaded it before here. Yeah. Now I will add it to MATLAB. This is the location of the driver. Location. Yes. So we will add to PID the selected folder and subfolder. So it's done. We install the driver to the MATLAB. Now I'll talk the first controller, PID controller. Here, this controller have three parts: input, controller, and the output. The input will have two parts: set point and present value. Set point is the value which I want the project will reach. The real water level will get it, and the present value in the present value. Yes, it's read from the ultrasonic sensor here. Now, and the next is the PID controller. It consists of three variable here: KB, KI, and KD. In this case, I use the method try and error to find out this value. We make the error, we try, and we get this KB, KI, and KD. That's all. And the output is the PWM, which I will use it to control the power of the pump the water to the tank. And this block is used for supply the power to the motors or the pump. That's all. This is the PID controller. And we will click scope here to observe the result. Two curve, the set point and the present value. And the next controller is Fuzzy controller. Here, it's the quite same as the PID controller. Three parts: input, controller, or output, and output. The input is present value and set point, the same. But the input of the Fuzzy controller is the zero or between the present value or the set point. We make the subject block here to do it. And Fuzzy controller consists of 3 parts. It doesn't have the variable or parameters like the PID controller. It's a KD. It does not have it. And Fuzzy logic controller will have rules. The input here, the output here, or the main part is root. Rules here is added from here, from workspace. You can see this. Yes, the Arduino is display on the workspace, so I will add it to the Fuzzy model block here. That's all. The same input and the same output as the PID controller. PWM to control the pump, scope to show the result. That's all. And the last controller here is Fuzzy PID controller. As you know, in the PID controller, original PID controller, I will use the trial and error method to find out the KB, KI, KD. But in this controller, I do not do it. I will use the Fuzzy logic controller to adjust the KB, KI, KD automatically. But in this case, I just adjust the main variable KB, just KB, and the same KI, KD as the PID controller. Input is set point and present value, the same. Input the Fuzzy controller is the 0, the same as Fuzzy controller before. But this is different. The output of Fuzzy controller here ignores the PWM. This is the KB. The KB here will use to PID controller here, and the output of PID controller, this is the PWM to control the power of the pump. The order is the same. Motors here to supply the power, and scope show the result. That's all. This is the 3 models of controller that I use in my project.